problem, we're trying to find all the valid permutations of the parentheses. So we are given n pairs of parentheses, and we need to return a list of all the valid permutations. So in here, we have this assumption that n is larger than 0. And we need to make a clarification that all the valid permutation means in the set the left parenthesis should have a larger number than the right parenthesis. So so for the coding, so we're going to solve this problem with a recursive way. We consider that we consider for every we consider that we have two positions. So to fill this we can fill this position as with a left parenthesis or a right parenthesis. So we have two possibility for every position, and we have two n position in total. So we can draw the recursion tree like this. So for the position 1, we can have a left parenthesis. According to our clarification, we couldn't have a right parenthesis since there is no left in front of it, and it's the same as level 2 and level 3, and this tree will stop at level 2n. For our coding part, we will start a method with the return of list of string, which contains all the possibilities of the permutation, and we will have a int input as n. So first we will initialize this our result as the list of string, and we will illuminate the corner case. To solve this problem, we need to have a string builder to get all the possible strings as a result, and we will initialize two int to represent the number of left parenthesis and number of right parenthesis. And then we will call up a helper function, and with all the input we defined above. So for the helper function, we will have this recursion function, and we first consider the base case of the recursion. So we need the base case is when we reaches the last layer of the recursion tree, which means the left parenthesis has a number of n, and so as the right parenthesis. So if it's the case, we need to stop, which is return, and we need to add the string we just built into the result. If it's not in the corner case, we can consider if the left parenthesis is run out. If it's not run out, we will append this right parenthesis in our result, and goes to the next level of recursion. And after we finished, we need to come back and delete the element we just appended to go back to its origin, to go back to the original node. And also we have another option to add the right parenthesis, and that's only when the right parenthesis has a number smaller than left. So we can, in this case, we can append the right parenthesis, and it goes to the, similarly, it goes to the next level of recursion and come back and delete the last element we append to recover the node on this level. So for the time complexity, we will have one node and two on the level 1 and two nodes for on the level 2, and if we don't consider the and we will have this one node on the layer 1, and we have this two node on layer 2, but we just didn't consider it. So if we consider it, it will have the 2 to the factor of 2n number of nodes in the last layer. So for the maximum number of nodes, we will have 2 to the factor of 2n. So for each node, we will have a time complexity of 0.1. So the total time complexity should be 2 to the 2n. And for the space complexity, it's the height of the recursion tree, so it should be 2n. And it's same as n.